Question 8 asks for the x-intercept for this function. Now x-intercepts happen when our graph crosses the x-axis. So if you had a graph like this, maybe it looks like, I'm just making a random graph. Our graph does not necessarily look like this one. These are x-intercepts. Look, the y-coordinate, there might be some number for x, like this might be 3. The y-coordinate of the x-intercepts are always 0. So you find x-intercepts by plugging in 0 in for f of x, because f of x is like our y-coordinates, right? So here's the function. I'm going to plug 0 right in here. And to solve this equation, the first thing we should do is we should multiply both sides by the denominator there. Okay? I'm going to multiply both sides by x squared minus 9. That's going to make this cancel out. And then when you multiply it to 0, it makes that side equals 0. So it makes things nice and easy here. We get 0 equals x squared minus x minus 12. Now from previous math classes, we might recognize this as a quadratic. It's something that we can factor, okay? And the way we factor, or the other option is the quadratic formula if you're really comfortable with that, okay? But the way we factor is we make two parentheses, start them off with an x, and then you're going to find two numbers that multiply to be negative 12, but they add up to be negative 1. And so that combination is minus 4 and plus 3. Negative 4 plus 3, that makes negative 1. Negative 4 times 3, that makes negative 12. So this is the factored form. And then to keep going from there, you set each factored piece equal to 0. So I'm going to set the first parentheses equal to 0 and the second parentheses equal to 0. And so when you solve, you get x equals 4 and you get x equals negative 3. Those are our two solutions, and you'll want to just go back and check those solutions though for the intercept, because look, if you were to plug in negative 3 back into the original function, you'd have a divide by 0 error. So we actually don't have that as an intercept. Okay. So the only x-intercept is 4. We got two solutions when we solve that equation, but only one of them works, because if you try to plug the other one in, it's actually not even in the domain of the function. Okay, so that's the x-intercept. You'll like the y-intercept a lot better, because look, y-intercepts, like if you have this for a graph, this is your graph of your function, the y-intercepts are where it crosses the x-axis. It might be like 0, 3. Y-intercepts happen when the x-coordinate is 0. So what we have to do is we just have to plug in 0 in for x in the function. So it's easier because we just have to simplify. So 0 squared is 0, 0 minus 0 is 0, 0 minus 12 makes negative 12. 0 squared is 0, 0 minus 9 makes negative 9, so this is 4 over 3. So, oh, and I'm very sorry. We need to go back here. They want them as points. I didn't read the full instructions. 4, 0 is the x-intercept as a point. Okay. The y-intercept. We said y-intercepts, they happen when the x-coordinate is 0, and the y-coordinate for in our case was 4/3 when we solved. Very sorry. I should have noted that they wanted as points. Now vertical and horizontal asymptotes. I'll go into those in kind of brief detail. Your text has those, and I also have videos just totally dedicated to vertical and horizontal asymptotes. Just let me know if you have trouble finding those on my YouTube page here. But a vertical asymptote happens where we have a divide by 0 error. Okay. So look at the bottom of the fraction. X squared minus 9. If you plug in 3, 3 squared makes 9, and 9 minus 9 makes 0. If you plug in negative 3, negative 3 squared gives us 9, 9 minus 9 makes 0. So those are the two vertical asymptotes. It says list of numbers separated by semicolons. So we're going to type 3 semicolon negative 3. And then horizontal or slant asymptotes. Slant asymptotes happen when the power in the top is 1 higher than the power in the bottom. So look, the highest power in the top is squared. The highest power in the bottom is squared. So there are no slant asymptotes. We can have horizontal asymptotes. They follow these rules. If the power in the top is bigger than the bottom, no horizontal asymptotes. The power is bigger in the bottom, y equals 0 is your horizontal asymptote. If the powers are the same, it's a ratio of the leading coefficients. And all that means is it's a ratio of these first numbers. So like in the numerator, we have x squared minus x minus 12. The leading coefficient there is a 1. The leading coefficient is the number next to the highest power. And same thing on the bottom. The leading coefficient here is a 1. Okay, so it's a ratio of the leading coefficients. It means the leading coefficient of the top part divided by the leading coefficient of the bottom part. So y equals 1 is our horizontal asymptote. And then we have to sketch the graph, so we got to choose which one is correct. I'd recommend, if you're having trouble with finding those asymptotes, go to desmos.com to graph. And our function was x squared minus, I got it written right there. So you can type it in like this: make parentheses, put a division symbol, and make other parentheses. That way you have your fraction to start off. And to make something squared, I'm going to hold shift and press the 6 key. That lets me get to my exponents. And then you have to arrow down to the right, okay, to get back to normal numbers, to get out of the exponent place. Okay, and so there's our graph. Look, there's our horizontal asymptote at y equals 1. And there's our vertical asymptote at x equals 3. Oh, shoot, I missed something. We need to go back. Very sorry about this. Remember, -3 was not part of our domain, right? That's not going to be a vertical asymptote. So watch out if you had already done that part of the question. -3 is not a vertical asymptote. And the reason is because if you factor the top, it's x minus 4x plus 3 over x. And then if you factor the bottom, it's x minus 3x plus 3. If you were to factor these, the x plus 3's cancel out, so you actually only have 1 divided by 0 error. So just watch out if you already did that part. You got to go back. There's only one vertical asymptote for this function. Okay. So to sketch the graph in Desmos, we want those two asymptotes at x equals 1. This one looks good. Sorry, at y equals 1, there's an asymptote. At x equals 3, I think that's our winner. Oh, okay. So this one down here is really close. X equals 3, y equals 1. That has the same vertical asymptotes. I don't see the difference yet. Huh. It's like those things in the newspaper. Can you spot the difference? I don't see the difference between this one here . X and Y intercepts are the same too. And this one down here. So if you get the graphing part wrong, message me, because this one I don't see a difference in those graphs. Alright, so that's everything. Let me just submit and make sure it checks out. So there we go. There's all the correct answers for question 8. With that correction, I had 2 different places I had to go back on, so it's a big question, but